Unit 7, Lesson 3, so growth and decay. So this is just the idea of you can have sequences that grow and sequences that decay. That's just common sense in terms of patterns. Very applicable section, talking about finance, talking about different patterns, how they can grow and decay and all that kind of stuff. So we're just going to go through some real-life scenarios that apply to these patterns for arithmetic sequences. Okay, so BP, Birthplace Forest Program in Calgary, enables parents to honor their children by planting a tree when their child is born. At the same time, this shows a concern for the urban environment by encouraging the growth of city forests. Some of the trees which have been planted are evergreen trees which grow up to 12 to 18 inches per year. The program was launched in the year 2000. Now, before I get started any further, the hardest part about these is accounting for your starting year. Okay, so what I mean by that, if you have a tree that is, let's say it was 18 inches when you planted it, if your T1 is 18, remember, that is before any growth happened. So you need to make sure that, like, everybody gets confused of where do I start my T1. You can start your T1 anywhere you want. You just have to know what that means, okay? So, like, for example, it says how many years of growth would be needed. If you put T1 as 18, which is what it started at, there wasn't a growth year yet because that's where the tree was planted, okay? So I'm just talking in general terms. People struggle with T1 versus T0. I call it T0 because nothing's happened, okay? But we'll get to that. Okay, so evergreen tree is 6 inches high, was planted in 2000, has a growth rate of 15 inches per year. 2 students were asked to determine the height of the tree in June of 2011. Joel formed a arithmetic sequence beginning 6/21/36. Jenna formed one that was 21/36/51. This is what I'm talking about. So Joel started with 6. So he started with planted. Jenna started at 21. So she started after it grew by its 15. So that was her T1. Do you see how I'm saying the difference? You can get the same answer. You just have to know what you're saying, like where you're at. Okay? So turn the formula for the exact general term for Joel's. So Joel, what he would do in terms of this would be, let's go back to A real quick. I skipped A, didn't I? What A was saying, use the formulas of previous lesson to determine each student's answer to the problem. So Joel would do, this is his. Okay, his A is 6, his common difference is 15, and his N is 12. Okay? So the reason his is 12, you're saying, why is his 12? Because he's counting the year it did, like before it grew. So he has to kind of add one on to a growth year because essentially he's counting the year 2000. See how we started 2000, 2011? You guys obviously know that's 11 years. But if he starts at 6, that's where it was when it was planted in 2000, and then it grew for 11 years. So that's what I'm talking about, understanding that difference. The 12 is the years, the terms from 2000 to 2011. And so here's what's happening. Joel is counting a 0 year. Jenna is not counting the 0 year. So when I say 2000, 2011, you would say 11 years, right? But obviously if I write 2000, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, how many numbers is that? 12. That's why Joel's using 12, because he's counting the 0 year. Jenna's actually starting at the first year of 15. That's their difference. That's what I'm talking about. So you just have to know where you're at. Okay? Both can be okay, as long as you know where you're at. So that's what he uses. And so his form is going to be, his T12 is 6 plus 11 times 15. He gets 171. She does A is 15. She does N for her is 11. And her common difference is the 15 as well. So in her would be term 11, 15 plus 11, so 10 times 1, 21. Her age, oh yeah, her age is 21. Sorry, thank you. Why did I put 15? It makes no sense. Her age is 21. Thanks. That's why mine was looking bad. Okay, good. And so then, what was that? 10 times. Should be 10 times 15 is what I was writing. So that's 171 as well. So they get the same answer. That's the point. They both can be effective if they're used correctly. Okay, determine the formula for the general term sequence for joules. So what was his generals? His is simply, we're just going to simplify what he did. He has T sub n is A plus n minus 1 D. And we're going to plug everything in that he used. So he used 6. He used 12. Okay, but they're going to leave the n here because they want general. If they say general, that means you leave the n. That's your growth number. And it grew by 15 every time. So what you're doing, essentially, you're making a linear equation. So you're making a linear equation that represents Joel's tree height. So what I'm going to do is I'm just going to simplify this. So I'm going to distribute 6 plus 15n minus 15. So his general equation is 15n minus 9. 6 minus 15 is negative 9. So how you can test if this works? Joel counted 6 as his first term, right? So if I put 1 there, what's 15 times 1? 15 minus 9, 6. That linear equation is representing his pattern. So you can kind of check to see if it's lining up. So then Jenna's is similar, except for she starts with 21. So she says her T sub n is 21 plus n minus 1 times 15. So then hers is T sub n 21 plus 15n minus 15. Let's do the n in front so it looks linear. So it's 15n plus 6 is hers. Again, they both work. You just got to know where you're at in terms of years. Okay. All right. Explain why the formulas B and C are different. They're different because it's the starting year. So you just say they're different because they start at different times. So different. A values. If the tree continues to grow, which year will it reach 28 feet? We can use either person's form. I'll just go. I guess we'll just go. Okay, so we did all the growth in what though? 28 feet. We didn't go in feet. We were going in what? Inches, right? So we're going to convert feet to inches. So we're going to go 28 times 12. We get 336. So we're going to say 336 equals, and we'll just use the 15n minus 9. Now tell me what year in Joel's model that it's going to work. So if I add the 9, 345, divide that by 15, you get 23. So for Joel's, that's going to be 2000 plus 23. So 2023 is the year it's going to happen. Or sorry, 2022 is the year it's going to happen because you're counting zeros, what I meant to say. So for Joel's, because his starts, this is his T1, right? His T1's right here. So if I go 23 counting a 0, that's 2022 is his answer. If I do it with Jenna's, hers is going to be the exact year it's supposed to be. So it kind of doesn't count that 0 year. Okay, so if you do, I'll just do it real quick. You don't have to write this one if you don't want to. 336 equals 15n plus 6 minus 6 minus 6. You get n equals 22. So for hers, that is 22 years from 2000. So hers is a little bit more direct in terms of you don't have to worry about any plus 1 or minus 1. Okay. All right, so it's all about knowing the years. All right, let's look at the next one here. Questions on that? The 0 year, anybody still confused? Where? So that's years. Yeah, so that's for time. Okay. All right, so generating number patterns exhibiting arithmetic decay. So now we're looking at decay, so this is a good problem. You buy something like a car, in this case it's a printing press, but they always lose value. So in the year 1992, it depreciates in a value the same amount each year. 5 years after it was bought, the printing press had a value of $311,000. It had a scrap value of $2,900 in the year 2010. Okay, so it was bought in 1992. Okay, 5 years after it was bought, it was worth $311,000, and then in 2010, it was worth $2,900. So you see, it definitely was losing some value quickly, but it does say it was the same decay every time. Okay, so how do we use this information they're giving us? 5 years after it bought, what does that mean to us? T5, good. We want you to think of a T5. Yes, it is 1997, right? So, but yeah, but T5. So T5 is 311, okay? And then T 2010, so that was 18 years. So 5, so then that's, what is that then? T18. So after 5 years, it was this much. After 18 years, it was this much. So then let's go to Gavin here. Gavin, how can I find a quick way of figuring out what the rate is? Yeah, slope. And remember, it's this one first, right? Because it's going to be negative. We know it's depreciating, so we want it's going to be 2,900 minus 311,000 over 18 minus 5. That would give me the depreciation value. Can someone calculate that for me? See what the annual depreciation is. $23,700. Good. So $23,700, how much depreciated every year? That's a negative, so it went down that much when you calculate that. Good? You also could do a system of equations there. You could, we know A plus D, all that stuff. Okay? But good. I'll do part B just right above here. So determine the purchase price. So what's the purchase price, and how would I do that? Yep, 23,700 times 5. So we go 23,700 times 5. Okay, and then you're going to add that to this guy. Okay. So when you calculate that, you should get 429. Let's see here. Yeah, what did you guys get when you're calculating? Yep. 429,500. Good. That's correct. So there was almost $500,000 for a printer press. Not a printer. It's like one of those newspaper things. Those are expensive, so. Okay. Good. On to the last one here. We can relate arithmetic sequences and linear functions like we talked about over natural numbers. A pile of bricks is arranged in rows. So what they're saying here is that what does natural numbers mean, guys? Natural numbers, just what are they trying to eliminate? Above 0 and decimals, right. Natural numbers are whole numbers. So they're saying this thing can only be whole numbers. So for example, things that can be whole numbers. If I was counting shoes, we can't have half a shoe, right? We can't have half a brick. Okay, you could, but it's not going to be effective for laying brick. Okay, so that's what they're talking about in terms of we can use natural numbers for real life situations. Okay, so complete the table of values showing the number of bricks in each row. So a pile of bricks is arranged in a row. There are 28 bricks in the first row, and the next one has 2 more than the previous. So it's going to go row 1, 28. Just fill this out real quick. Just a quick, easy table. All the way down to the 10th row. And it's going to be 30, 32, 34, 36, 38, 40, 44, and 46 lastly. Okay, and we're going to plot these ordered pairs just on a grid here. So we're going to plot 1 at 28. They have a line break for us, but they are going by 2s here. So 1 is 28, 2 is 30, 3 is 32, So you can see it's just going up linear like this. So it says determine if the range is the arithmetic sequence. Well, the range is the y values, right? We think range is the outputs. Our outputs is number of bricks. Is our number of bricks, what's their, does it have a range? The range, yeah, the range starts at 28 and goes up by 2's. So you would just say the range starts at 28, goes up by 2's. If it's 10 rows, then that's where it stopped, but there's more than that. Okay, so what you'd say is you have the range. I'm going to put AS for arithmetic sequence. And it has a common difference of 2. State the domain. What's the domain in this set? Yeah, they're whole numbers because rows, right? We're having whole rows. So it's our natural numbers of rows. Starting at 10. Or sorry, starting at 1. Sorry. Up to 10 for our chart. Why does the graph not have an intercept on the vertical axis? So why is there not a dot on the vertical axis? There's no such thing as 0 row. Non-existent. All right, write the equation for the number of bricks in a row n as a function of row number r. So we're trying to write an equation for this now. So we're going to use our arithmetic sequences, all right? So this is the last thing we're doing. So what is our general term? General term, again, is this. Okay, that's what it is. And so what we're going to do is we're trying to write that in terms of r and bricks n, okay? So it's a little bit backwards because bricks n is the, or this is the output, right? That's how many bricks they're going to be. So this is our n in terms of what they're saying. I don't like to use n again, but they did. Sorry. What's our a for what they just talked about? What's row 1? 28. So 28. We leave n as n in the actual problem, right? Which I think is dumb because they switched it on us. It's fine. Rn. This is, I remember that, I don't like this, I'm sorry. No, it's fine. Rn for the problem is rows. So they make your n r, but then they make your total number of bricks the n, which I think is weird. But the point is we do the same thing we've been doing, we just count r as n. So this is going to be r minus 1. What's the common difference? We're going to be done. That's why it's not a big deal. This is a 2. And now we're simplifying this. So essentially, guys, if you look at it, what they're saying is that n is our y, r is our x in the function, based on what they're asking for. So this is going to be n equals 2r plus 26. That's the equation for the rows and the number of bricks. So how do you know this works? Well, let's try it. Let's plug in a 6. Let's plug in a 6. Look at your table. What do we expect to get with a 6? 38. So if I put it in there, 2 times 6 is plus 26, 38. So we represented the equation of bricks in terms of rows. Okay? All right. Stop there.